3 billion miles from Earth, NASA's New Horizons spacecraft, moving at speeds that would get it from New York to Los Angeles in about 4 minutes, pointed cameras, spectrometers, and other sensors at Pluto and its moons. These are distant worlds that humankind had never seen up close, and the mission was able to record hundreds of pictures and other data that would forever change our view of the outer solar system. Let's talk about the Horizons spacecraft and the terrifying discoveries it made on Pluto. NASA's New Horizons became the first spacecraft to visit dwarf planet Pluto in July 2015. The far-traveling spacecraft also visited a distant Kuiper-Belt object, Ultima Thule, now called Arrokoth, in January 2019. New Horizons is still exploring our solar system, and on April 17, 2021, the spacecraft reached a distance of 50 astronomical units from the Sun. Observations from New Horizons are continuing to revolutionize our understanding of solar system objects orbiting far from the Sun. The spacecraft's extreme distance from Earth makes it only the fifth to venture so far from home, the others being Pioneer 10 and Pioneer 11, and Voyager 1 and Voyager 2. Only Voyager 1 and Voyager 2 have traveled so far that they entered interstellar space. According to NASA, New Horizons is expected to enter interstellar space in the 2040s. New Horizons is the first of NASA's New Frontiers mission probes, which are medium-class missions designed to explore different destinations in the solar system. The mission was initially selected for funding in 2001, but was excluded from the NASA 2003 budget. Funding for the mission was reinstated after New Horizons was listed as a top priority in the Planetary Science Decadal Survey of 2003 through 2013, which identifies scientific targets for future exploration. Spacecraft typically have a set design lifetime, similar to warranties on electronics or cars. Over time, solar particles, cosmic rays, and other phenomena can degrade the surface of the spacecraft or mess up the electronics. This makes long missions like New Horizons especially challenging, requiring backup systems and a source of power to keep the spacecraft alive far away from the Sun. The craft launched on January 19, 2006, aboard an Atlas V rocket from Cape Canaveral Air Force Station in Florida. A power outage and high winds had delayed 2 previous launch attempts, but New Horizons made it safely into space on the 3rd try. Thanks to the New Horizons mission, we now know more about Pluto and other bodies from the Kuiper Belt, such as moons and frozen volatiles. The discoveries have opened a new era in the scientific world, and maybe they will be an inspiration for future investigations. Let's look at some of the most significant discoveries the mission made about the distant dwarf planet. Sometimes you just have to follow your heart, and Pluto seems to have taken that advice quite literally. Pluto's heart, one of the signature features New Horizons observed on approach and imaged in high resolution during the flyby, is a vast million-square-mile nitrogen glacier. The heart's left ventricle, called Sputnik Planitia, literally forced the dwarf planet to reorient itself, so the basin now faces almost squarely opposite Pluto's moon, Charon. This is due to a process called true polar wander. It's when a planetary body changes its spin axis, usually in response to large geologic processes. Sputnik Planetia's current position is no accident. It's a cold trap, where nitrogen ices have accumulated to make an ice sheet that's at least 2.5 miles thick. The constant imbalance of that hefty mass, combined with the tidal yanks and pulls of Charon as it orbited Pluto, literally tipped the dwarf planet so the basin aligned more closely with the tidal axis between Pluto and Charon. This event was also likely responsible for cracking Pluto's surface and creating the many gigantic faults in its crust that zigzag over large portions of Pluto. The basin's thought to have formed to the northwest of its present location and closer to Pluto's north pole. And should ices continue to accumulate on the basin, Pluto will continue to reorient itself. Gathered ice may not be the only thing that helped reorient Sputnik Planitia. New Horizons data from the basin indicated there may be a heavier mass beneath it that played a part, and scientists suspect that the heavier mass is a water ocean. This is an astonishing discovery that could make Pluto an elusive ocean world in the same vein as Europa, Enceladus, and Titan. Several other lines of evidence, including tectonic structures seen in New Horizons imagery, also point to an ocean beneath Pluto's crust. Sputnik Planitia was likely created some 4 billion years ago by the impact of a Kuiper Belt object 30 to 60 miles across that carved out a massive chunk of Pluto's icy crust and left only a thin, weak layer at the basin's floor. A subsurface ocean likely intruded the basin from below by pushing up against the weakened crust, and later the thick nitrogen ice seen there now was laid on top. Recent models based on images of the planet suggest that this liquid ocean may have arisen from a rapid, violent formation of Pluto. Enormous faults stretch for hundreds of miles and cut roughly 2.5 miles into the icy crust, covering Pluto's surface. One of the only ways scientists reason Pluto got those fissures, though, is by the gradual freezing of an ocean beneath its surface. Water expands as it freezes, and under an icy crust, that expansion will push and crack the surface, just like an ice cube in your freezer. But if the temperature's low enough and the pressure high enough, water crystals can start to form a more compact crystal configuration, and the ice will once again contract. Models using New Horizons data showed Pluto has the conditions for that type of contraction, but it doesn't have any known geologic features that indicate that contraction has occurred. To scientists, that means the subsurface ocean is still in the process of freezing and potentially creating new faults on the surface today. If Pluto is an active ocean world, then that suggests that the Kuiper Belt may be filled with other ocean worlds among its dwarf planets, dramatically expanding the number of potentially habitable places in our solar system. But while Pluto's liquid ocean likely still exists today, scientists suspect it's isolated in most places by almost 200 miles of ice. That means it probably doesn't contact the surface today, but in the past, it may have oozed through cryovolcanic activity. On Earth, molten lava spits, drools, bubbles, and erupts from underwater fissures through volcanoes sitting miles high in and protruding from the oceans, like on Hawaii. But on Pluto, there are numerous indications that a kind of cold, slushy, cryo-lava has poured over the surface at various points. Scientists call that cryovolcanism. Wright Mons and Picard Mons, two large mountains to the south of Sputnik Planitia, each bear a deep central pit that scientists believe are likely to be the mouths of cryovolcanoes, unlike any others found in the solar system. To the west of Sputnik sits Viking Terra, with its long fractures and grabens that show evidence of once flowing cryo-lavas all over the surface there too. And farther west of Sputnik Planitia is the Virgil Fossé region, where ammonia-rich cryo-lavas seem to have burst to the surface and coated an area of several thousand square kilometers in red-colored organic molecules no more than 1 billion years ago, if not even more recently. Pluto joins the ranks of Earth, Mars, and a handful of moons that have actively flowing glaciers. East of Sputnik Planitia are dozens of nitrogen ice glaciers that course down from pitted highlands into the basin, carving out valleys as they go. Scientists suspect seasonal and mega-seasonal cycles of nitrogen ices that sublimate from ice to vapor, waft around the dwarf planet, and then freeze back on the surface are the source of the ice of the glaciers. But these glaciers are not like our own water ice glaciers here on Earth. For one, any melt within them won't fall toward the bottom of the glacier. It will rise to the top because liquid nitrogen is less dense than solid nitrogen. As that liquid nitrogen emerges on top of the glacier, it potentially even erupts as jets or geysers. Additionally, there is the fact that some of Pluto's surface is composed of water ice, which is slightly less dense than nitrogen ice. As Pluto's glaciers carve the surface, some of those water ice rocks will rise through the glacier and float like icebergs. Such icebergs are seen in several New Horizons images of Sputnik Planitia, the largest of Pluto's known glaciers, which stretches more than 620 miles across, about the size of Oklahoma and Texas combined. These amazing discoveries are just some of the mysteries the mission has helped uncover about Pluto and our solar system. New Horizons is now nearly 300 million miles beyond Pluto, speeding to its next destination deeper into the Kuiper Belt, following NASA's approval of an extended mission. The craft is sure to send back more data, which will continue to improve our understanding of the universe. Please remember to like, subscribe, and hit that bell icon to join us as we continue to track the craft's journey into interstellar space. Do you think New Horizons will eventually find a new planet outside our solar system? Please share your thoughts in the comments below.